Okay, so I said the linear function would usually have a constant value. A constant value means that a value that has nothing to do with changes in the independent variable. Okay, so for example, we say as the price goes up, the quantity goes up, or you can say as the price goes up, the quantity goes down. For example, if you think about it, if the price of apples go up, or if the price of meat goes up, then people are going to buy less meat. The reason people are going to buy less meat when the price goes up, two reasons. One of them being that the meat becomes less valuable to you. You say if chicken is going to go from $2 a pound to $7 a pound, well, I'm not going to eat chicken. Okay, they can have it. So that's an attitude. If the chicken goes from $2 a pound to $2.50 a pound, well, you know, instead of chicken, I'm going to buy something else. Either because you can no longer afford chicken, or because something else is worth more than chicken to you at that kind of money. Okay, and so we usually will specify a function as a being the constant plus b being the rate of change times p. Now, if you think about your electricity bill, for example, whether or not if you shut off all the lights in your house and go away, you're still going to get a bill, because there's a fixed amount that the company is going to charge you because they provide you the service, fixed amount. Way back in those days, I don't know how long you've been around, but I've been around for a very long time. Telephone long distance calls used to have a constant amount. If you make a long distance call, you pay. If you don't make a long distance call, you don't pay. But again, there's a fixed charge. Even if you don't make any calls, even if you just have a phone, there's a fixed charge of say $10. And then for every minute that you call, that's say 5 cents. And so for every additional minute you call is B that you have here. And then P will be, say, the number of minutes. So your bill, B, depends on some fixed charge plus B times N, B being the rate of change, say 5 minutes, 5 cents per minute. And M is the number of minutes. And so you evaluate the bill. And so this is what we do in linear functions. And so, for example, if you look at this linear function, this is a linear function here. I'm going to make it big. Okay. It's a linear function. So this linear function Q of P, which is the quantity that depends on P, the quantity supplied, QS, depends on P, can be written as a linear function 13,000 plus 2,000 times P. And so the minimum value of Q is 13,000. And for each time that P changes by 1, Q will increase by 2,000. As you can see here, the function could also be a negative value. There could be a negative relationship, okay? But this simply says plus 2,000 times P, which means that each time P changes by 1, Q will increase by 2,000. But we could also write a function like Q equal to 25,000 minus 500 times P. You can write a function like that. So this one does a negative relationship, okay? But in this one, does a positive relationship. And so, like in this function, when P goes up, When P goes up, changes by 1. When P changes by 1, let us change. When P changes by 1, then Q will change by a negative number, 500, okay? By the opposite of the change in P. So if P goes up, Q will go down. If P goes down, Q will go up. So, but in this case, when P goes up, Q will go up. When P goes down, Q will go down. So we can use the form of the function to evaluate what Q will be when P is 6. So we say evaluate Q of 6, evaluate Q of 10, and evaluate Q of 5. There's 3 separate problems here. And so we can easily evaluate this, okay? And easily evaluate this by saying Q equal to 13,000 plus 2 times 10. So I'm just going to choose that arbitrarily. And so we have 13,000 plus 2 times 10 is 20. Actually, 2,000 times 10. Okay. Plus 2,000 times 10, which gives you 20,000.
20,000.
All right. And so the answer to this problem will be, what do you call it?
33,000.
So it's that simple. Okay. It's that simple. So what you have like in your homework assignment is a situation where you read off a function. Okay. So I'm going to stop share this. And I'm going to pull up the assignment. I've seen some students in the past they say they have difficulty looking at this. And so, for example, let me see if I can make this a little bigger. All right. And so essentially what this is simply saying is, all right, you have average cost of P of cells for the quantity Q. And so Q is the independent variable and the cost will be here. And so what if we produce 72 and so the average price will be like 275. So
XY axis, right?
Yes. So if we are here at 72, next time I'm going to pull up a pen. If we're here at 72, if we produce 72, the average price will be 275 per the unit. Okay. Yeah, this is what is it that we're cell phones. Okay. So if we produce 78, the average price will be 300 per cell phone. Okay. And so the minimum at the lowest point of this graph, it looks like 54. If we produce 54, the average price is 225. So as you can see, if you produce less than 54, your average cost is high. If you produce more than 54, your average cost will start going up again. But as you are going between 0 and 54, your average cost is going down. And after that, the average cost is going up. This is something that happens in production processes. So this is just an illustration of what happens in production processes. And this is essentially what you have to do in this assignment. And then, of course, you can then apply it. You know, there are some applications there. You were asked to calculate profits. You were asked to calculate total costs. And again, it's pretty much what you have in your homework assignment. So, I mean, having explained this, if you have any further questions, I will answer them. If not, you can always break off whenever you want. But next week, I'm going to come up and provide much more extensive explanations so that if you have issues, at least we can mitigate them before you begin to do your homework assignment. This week's homework assignment is due by Sunday, okay? And so today is still Thursday, so you have time. If there's something that you don't understand, at least now you have time to go and revise your submission. And so next week, Thursday, we will do the same thing. But I would suggest that you come with your questions ready. In that way, if there's something you can't solve, or if you want another illustration, send it to me in advance and I'll prepare a solution and bring it to the office hour.
Okay.
All right.
Thank you.
Any other questions?
No, not right now.
All right. Okay. Good night, everybody. I'm going to still hang around. I'm just not going to say anything. I will hang around just in case somebody comes in with a different question. Somebody has other issues.
Okay, great. Have a good evening.
You too.
Thanks. Bye-bye.
Hey, Professor, how are you?
I am okay. Kimani, do you have any questions for me?
It's really Vivian Blight. Kimani is my son. I didn't know that his Zoom was logged on it, but I was the one that emailed you about the test that I wasn't seeing it, and I really have to tell you thanks. Like, thank you for actually assisting. So I was able to do the test.
So what happened is we went through a new system.
Yeah.
They restructured the way the Blackboard is set up. And so I realized that they locked the assignment. You can see it, but it's locked. So I went and opened it.
Oh, okay. Yeah, I really appreciated it, man. It really helped. And thank you for the speedy response as well. So I was able to get it done.
You're very welcome. I'm glad to work with anybody that has difficulty. And thank you for bringing it up, because I would never have known that in the new system, they have this double lock. And so they open one side and they lock the other side. And so I discovered it, and so I went and unlock it.
Understand. Thank you, Professor.
All right.
Have a good evening.
You too. Yes, sir.
All right. One more thing. All right. I saw the graph that you were doing. I already submitted my assignment, but on the graph, when I was looking at it, your graph looks clearer than my graph. I don't know what happened, because your one is clear to show the lowest point. And I see it clear on yours, but when I was looking at mine, it did not touch the line for 225. So my assumption was that it was at 230. Is it possible for me to
that's good. That's good. That's good.
Oh, that's still good?
Yes, that's still good, because when you're reading the graph and it's, it's approximate. Again, what you could do is you just, usually on the laptop or on the computer, on the right side, you see where you can increase the size of what's on the screen. You can increase it a little bit if you want to be more accurate, but 230 is fine.
Oh, okay. So I don't have to resubmit. I'm good.
No, you're good.
All right. Once again, thank you again, Professor. Enjoy the weekend.
Right. Enjoy your weekend.